Hello friends and my dear students, I welcome you all to my channel. I hope you are all well and your studies are also going on well. In this part 10 video on the concept of limits, I will solve 10 example problems which are based on the standard results of trigonometric and trigonometric functions mainly, which are sin x that I discussed in the part 9 video. This video is part of the playlist Problematic Mathematics for class 11, where I primarily discuss about the key concepts and formulas for problem solving oriented towards JEE Mains, JEE Advanced and WBJEE. If you find this video beneficial, then please like it, share it with your friends, and please support me to grow my channel. Subscribe to my channel, like the videos and share them with your friends, and do not forget to press the bell icon so that you will be notified by my future videos. Okay, so this is set 1 of 10 problems. These are very simple problems, straightforward problems. Should be very easy for you to solve these problems. But since these are trigonometric, these limits problems are based on results, standard results of trigonometric functions. Your concept of trigonometric ratios and identities should be very strong. Okay, so the first problem is limit x tending to 0. We have sin ax by sin bx whole to the power n, where n is a natural number. Now clearly we can see that this will be equals to the power n, the power of n, which is the natural number, has practically no role in finding the actual limit. So this will be limit x tending to 0. We can say this is basically a part of the algebra of limits. So this is equal to limit x tending to 0 sin ax by sin bx, and this whole raised to the power n. Okay, so let's say I am calling this limit to be L. So eventually the answer will be L to the power n. So we have to find L. So L is equal to limit x tending to 0 sin ax by sin bx. Since if you have watched the previous video, the concept is that I will create the denominator, I will create ax as the denominator to sin ax, and also I will create bx as the denominator to sin bx, and I will adjust ax and bx. Okay, so this is equal to limit x tending to 0 sin ax by ax. I am adjusting ax, and then I have multiplied by 1 by sin bx by bx, and I am adjusting bx. Now limit x tending to 0 sin ax by ax, it will be equal to 1, because we know that sin fx by fx when fx tending to 0 is 1. In this case fx is nothing but ax. So this will be 1. Also sin limit when x tending to 0, limit of sin bx by bx will also be equal to 1. So this is equal to now limit x tending to 0 ax by bx, which is equal to x will cancel out. This is nothing but a by b. So L is a by b. So the answer is a by b whole to the power n. Let's see the next problem. Limit x tending to 0 limit x tending to 0 sin square 2x divided by sin square 4x. Again we can write it as this is equal to limit x tending to 0 sine 2x divided by sine 4x whole square. So this will be equal to limit x tending to 0 sine 2x by sine 4x whole square. The concept, this is the concept of algebra of limits. It says that if we have limit x tending to a fx is equal to L, where L is a finite real number, then this implies that limit x tending to a fx to the power small n, where n is a natural number, will be equal to L to the power n. So now let's say this be L, that is limit sin 2x by 4x when x tending to 0 be equals to L. So then the final answer will be L square. We have to find L. So L is equal to limit x tending to 0 sin 2x by 4x. We know how to solve it. We will create the denominator of 2x to sin 2x, and I will create the denominator of 4x to sin 4x, and I will adjust 2x and 4x. This is sin 2x divided by 2x multiplied by 2x, and then I have 1 by sin 4x. I will create 4x and I will adjust 4x. So this becomes a limit of sin 2x by 2x when x tending to 0 is 1, and also limit of sin 4x by 4x x tending to 0 is 1. This is from the concept of this is based on the concept that limit when fx tends to 0 sin fx by fx is equals to 1. So now this becomes limit x tending to 0 2x by 4x becomes half. So this is equal to half. So L is equal to half. So then the limit becomes equals to L square. L is half, so half square, which is 1 by 4. Let's see the next problem. Tan 2x minus sin 2x divided by x cube, limit x tending to 0. In this type of problem, always try to, it is better if you convert everything in the form of sin x and cos x, in terms of sin and cos. So this is limit x tending to 0. Tan 2x is sin 2x by cos 2x minus sin 2x, and always remember, whenever you are given trigonometric functions, and if you have to apply the standard results of the trigonometric functions or even circular functions, you have to rearrange the entire given function as a factor of function of tan or sin or cos divided by x cube. So this is equal to limit x tending to 0. I can factor out sin 2x from the numerator. So this will be sin 2x 1 minus cos 2x minus 1 divided by x cube. This is equal to limit x tending to 0 sin 2x 1 minus cos 2x divided by cos 2x multiplied by x cube. Now cos 2x won't be a problem, because when x tending to 0, cos 2x tending to cos 0, which is equal to 1. Now one important concept you must always apply whenever you have anything of the form 1 minus cos kx, then always use this, you always rewrite this as 2 sine square kx by 2, that is 1 minus cos x is equal to 2 sine square x by 2. Always try to express 1 minus any expression of the form 1 minus cos kx as 2 sine square kx by 2. Okay, so now this becomes limit x tending to 0, we have sine 2x, and 1 minus cos 2x is 2 sine square x, and we have cos 2x when x tending to 0 will be 1, so we need not write it, so we have x cube. Actually it will be 1 multiplied by x cube. Okay, so we have sine 2x in the numerator, we have sine 2x multiplied by 2 sine square x. Obviously I have to use the standard result of sine x by x or sine fx by fx when fx tending to 0 as 1. So I have to create that form. So limit x tending to 0 for sine 2x, I need 2x. Okay, and since I have created 2x in the denominator, I will have to adjust it, and 2 sine square x, now I am bringing the 2 sine square x to outside, and sine square x to apply the standard result of sine fx by fx tending to 0 as 1, I need x square as denominator to sine square x. So let's say I have sine square x, I am creating the denominator sine x square, but then I have to adjust it. X square, and I have whole divided by x cube. Okay, so now this becomes 2 twice limit x tending to 0, sine 2x by 2x limit x tending to 0 will be 1. And also you will see that also limit of sine square x by x square when limit x tending to 0 will also be 1. Actually it will be limit of it will be square of limit x tending to 0 sine x by x whole square, and sine x by x limit x tending to 0 is 1. Okay, so we are left with 2x cube, we are left with 2x cube by x cube, which is 2. So this becomes 4. Okay, let's see the next problem. Sine 5x minus sine 3x divided by sine x. Now whenever you see in the limiting problem any expression of the form sine a minus sine b, possibly a and b will be some function of x, then always use this formula. We must express this sine a minus sine b as a factor of a sine or sine and cos. So sine a minus sine b, the formula is twice sine a plus b by 2 multiplied by sine a minus b by 2. So sine a minus sine b has been factorized as a factor of sine. So sine a minus sine b is equal to 2 into sine a plus b by 2 multiplied by sine a minus b by 2. Okay, so then this becomes a limit x tending to 0 2 into sine a plus b by 2, a plus over here this is a is 5x and b is 3x. So a plus b is 8x by 8x by, okay, so this is 5x plus 3x by 2 multiplied by 5x minus 3x by 2 divided by sine x. So this is equal to limit x tending to 0 2 times, let's bring the factor of 2 constant 2 outside the limit. Okay, so this is 2 twice limit x tending to 0. Sin 5x plus 3x by 2 is sin 4x, and sin 5x minus 3x by 2 is x, sin x, and we have divided by sin x. Sin x. Let me see if I have done any mistake or not. Sin a plus b by 2 multiplied by sin a minus b by 2, 2x, x, so out 0. This is coming to be 0, but why the answer is given as 2? 4x, 8x, 4x, 2, x cos. Let me quickly check if I have written the formula for sin a minus sin b correctly or not, because my concept on trigonometry is really weak. I will quickly check that. Sin it is 2 cos. Okay, so I did it wrong. Sin a minus sin b is not sin a minus sin b is 2 cos a plus b by 2, cos a plus b by 2 multiplied by sin a minus b by 2. So this will be cos, this will be cos. Okay, so sin x cancels out. This is limit 2 times limit x tending to 0 cos 4x. Now limit x tending to 0 cos 4x is 1. So this is 2 into 1, which is equal to 2. So always remember that whenever you have any expression of the form sin a minus sin b in the limiting problem, always use this formula that sin a minus sin b is equal to, you have to express sin a minus sin b as a factor of sin and cos. So it will be 2 times twice cos a plus b by 2 into sin a minus b by 2, and cos a, you must remember these two formula very well. Cos a minus cos b is 2 sin a plus b by 2 multiplied by sin a minus b by 2. Okay, let's see the next problem. Sin 3x minus 3 sin x divided by pi minus x whole cube, x tending to pi. Now it is, first of all, sometimes it is easy, sometimes it is if you see, it is always a good idea if you can express the given limiting problem so that the limiting value is tending to 0 by doing some kind of substitution. So over here, let pi minus x be equals to h. No, let's not do this right away. Now, so we have sin 3x minus 3 sin x divided by pi minus x whole cube. Now, clearly we cannot, it is not of the form sin a minus sin b. We have sin 3x minus 3 sin x. So we have to use the formula of sin 3x. So sin 3x is 3 sin x minus 4 sin cube x. So this way the 3 sin x will cancel out, divided by pi minus x whole cube. So 3 sin x cancels out, and this is we have in the numerator minus 4 sine cube x. Let's bring out minus 4 as constant, limit x tending to pi, and then we have sine cube x divided by pi minus x whole cube. So we have to now do the substitution. Remember that the standard result is sine fx by fx tending to 0. So we have to somehow convert the tending value to 0 by doing some substitution of variable. Okay, so if we substitute pi minus x as h, so this will imply that h will tend to 0 as x tends to pi. So then the limit becomes minus 4 limit h tending to 0 and sine cube x will be pi minus h okay, and we have divided by h cube. Now okay, so this is minus 4 limit h tends to 0. So sine cube of sine pi minus h, sine of pi minus h is equal to minus sine h. So this is minus sine h cube by h cube. This is the minus will cancel out. This becomes limit 4 times limit h tending to 0 sine cube h divided by h cube. So this is equal to 4 limit h tending to 0 sine h by h whole cube. So clearly this will be equal to 4 multiplied by 1 cube, which is equal to 4. But the answer is minus. Let me see what mistake I have done. Sine pi minus h. I think sine pi minus h is not minus sine h, it is sine h. It is not sine of pi minus h is equal to sine h. So this is this. So we have minus 4, minus 4, minus 4. So the answer is minus 4. Let's see the next problem. It's similar to the previous problem, but this time we have cos 3x plus 3 cos x. The same idea. You have to express cos 3x. You have to decompose cos 3x using the formula of multiple angle, that is cos 3x is 4 cos cube x minus 3 cos x. So this is equal to limit x tending to pi by 2. Cos 3x is 4 cos cube x minus 3 cos x, so that we can cancel out 3 cos x. Pi by 2 minus x whole cube. So 3 cos x cancels out from the numerator. So this becomes let's bring out 4 outside. 4 times limit x tending to pi by 2 cos cube x divided by pi by 2 minus x whole cube. Now let's so we have to do the variable substitution. Let's do pi by 2 minus x is equal to h. So this will imply that h will tend to 0 as x tends to pi by 2. So then the limit becomes we have 4 times limit h tending to 0 cos cube pi by 2 plus h divided by h cube. H cube. Now what is cos of pi by 2 plus h? Cos of pi by 2 plus h will be equals to sin h. So this is equal to 4 limit h tending to 0. This is sin cube h. Cos of pi by 2 plus h is equal to sin h. So this is sin cube by sin cube h, sin h cube of sin h divided by h cube. This is equal to 4 limit h tending to 0 sin h by h whole cube. So clearly this is equal to 4 multiplied by 1 cube, which is equal to 4. Let's see the next problem. Question number 7. Sin x minus sin a divided by root x minus root a, x tending to a. So obviously I will use the formula. I will express sin a, sin x by sin x minus sin a as a factor of sin and cos. So this is limit x tending to a, sin x minus sin a is 2 cos x plus a by 2 multiplied by sin x minus a by 2, and we have 4 divided by root x minus root a. Okay. Now this root x minus root a, this is a rational fact, this is a rational term, this is an irrational term. We have to rationalize it by multiplying both the numerator and the denominator with root x plus root a. Okay. Now this is equal to, now when x is tending to a, cos x plus a by 2 will be cos a. So 2 cos a is a constant which we can bring outside the limit. So this becomes 2 cos a. Then we have limit x tending to a sin x minus a by 2 divided by root x minus root a. Okay. Let's rationalize. Now I have to, since there is sin x minus a by 2, I have to somehow bring x minus a by 2 in the denominator, and I will adjust it. So this is let's consider, let's solve this part. Let's say this be small l. So this is so L is limit x tending to a, we have sin x minus a by 2. I will bring, since x, when x is tending to a, x minus a by 2 is tending to 0. So I will bring x minus a by 2. Over here we know that sin fx by fx when fx tending to 0 is 1. In this case fx is x minus a by 2. This I will adjust x minus a by 2, and then we have divided by root x minus root a. Okay. So this is limiting value of sin x minus a by 2 divided by x minus a by 2 will be 1 when x tending to a. So this becomes limit x tending to a, and we have x minus a divided by 2 into root x minus root a. Let's factorize the numerator. X tending to a, x minus a, factorizing using the formula a square minus b square is equal to a plus b into a minus b. It will be root x minus root a multiplied by root x plus root a divided by, we have twice root x minus root a. Now we can cancel out root x minus root a, because from numerator and the denominator, because root x minus root a is not exactly equal to 0, it is near to 0. If it was 0, we couldn't have cancel it out, but we can cancel it out in this case, because root x a is x, the value of x is tending to a, which means that root x minus root a will tend to 0, it will not be exactly 0. So we can cancel it out, and if we substitute x as value of a, this becomes so L becomes twice root a by 2, which is equal to square root of a. So then the answer becomes 2 cos a into L, and L is root a. So this is twice root a cos a. Let's see the next problem. Tan 3x minus 2x divided by 3x minus sine square x when x tending to 0. In this type of problem, specifically for this type of problem, the way we solve is, we will take x as a factor from both the numerator and the denominator, and then we will get, so if you take x as a factor from both the numerator and the denominator, we get x multiplied by sine 3x by x, tan 3x by x. It is very near to the standard result of tan fx by fx when fx tending to 0 is 1. We can easily find the limiting value of sine tan 3x by x using the standard formula, and we have minus 2 divided by, if I take x common from the denominator, this is x multiplied by 3 minus sine square x by x. Okay, x cancels out. We can cancel out x from both the numerator and the denominator, because x is not equals to 0. X is not equal to 0. It is a value which is near to 0 but not equals to 0. Okay. Now limit x tending to 0. I have to adjust sine 3x. I will bring 3x in the denominator, so that I can apply the standard result of tan fx by fx when fx tending to 0 is 1, and I will have to adjust it 3x, and I have already x in the denominator. Minus 2 divided by 3 minus, now sine square x, to apply the formula sin fx by fx, fx tending to 0 is equal to 1, I will bring x square as denominator to sine square x. Sine square x divided by x square, and I will adjust it, and there was already x. So this now becomes limit x tending to 0 tan 3x by 3x multiplied by 3 minus 2 divided by 3 minus sin x by x whole square multiplied by x. Now the limiting value of tan 3x by 3x when x tending to 0 will be equal to 1. Also the limiting value of square of sin x by x when x tending to 0 will be 1. So this becomes 1 into 3 minus 2 divided by 3 minus 1 square, and x is 0. So this is 3 minus 2 is 1 by 3 minus 0, which is 3. So 1 by 3 is the answer. Let's see the next problem. So this is a very generic problem. We have sin ax plus bx divided by ax plus sin bx. For this kind of problem, again we will apply the same concept as we did in the previous problem, that is, we will take x as common factor. We will factor out x from both the numerator and the denominator. X tending to 0. In fact, you can factor out the bx from the numerator and ax from the denominator. So I am taking bx as a common factor from the numerator. So this becomes bx sin ax by bx plus 1 divided by, and from the denominator I am taking ax as common factor. Ax then become 1 plus sin bx by ax. Okay, so xx cancels out, we have b by a as a constant. Let's bring it outside the limit b by a, and we have limit x tending to 0. Now sin ax by bx is a very standard, you must if you can remember it is good, but limit x tending to 0, sin ax by bx is always equal to a by b. It is equal to a by b. We have, so this is b by a multiplied by limit x tending to 0, we have sin ax by bx plus 1 divided by 1 plus sin bx by ax. This will be equal to b by a multiplied by, now limiting value of sin ax by bx when x tending to 0 will be a by b. So a by b plus 1 divided by, again limiting value of sin bx by ax when x tending to 0 will be b by a. So this is 1 plus b by a. So this is b by a. After simplification we get a plus b by b divided by a plus b by a. So this is a by b, which is equal to 1. Let's see the last problem. Cos x minus cos 3x divided by x multiplied by sin 3x minus sin x. So we see the two expression cos a minus cos b in the denominator and sin a minus sin b in the, cos a minus cos b in the numerator and sin a minus sin b in the denominator. And we will always, whenever we see cos a minus cos b or sin a minus sin b, always using the trigonometric identities, express it as a factor of sin and cos. So this is limit x tending to 0. So cos a minus cos b is 2 sin x a plus b by 2. So sin x plus 3x by 2 multiplied by sin a minus b by 2, x minus 3x by 2. Divided by, we have x multiplied by sin 3x minus x. So sin a minus sin b, its formula is sin a minus sin b. I think I am doing something wrong. Cos, this is the formula. Sin a minus sin b is sin a minus sin b is 2 cos a plus b by 2 multiplied by sin a minus b by 2. So 2 cos a plus b by 2 multiplied by sin a minus b by 2. And okay, I think I am right. So cos a minus cos b will be 2 sin a plus b by 2 multiplied by sin of a minus b by 2. Cos a minus cos b cos A minus cos B. Cos A minus sin B is negative of, okay. So it is cos A minus cos B is negative of sin A plus B by 2 multiplied by sin A minus B by 2. It is negative of, okay. So this is negative of. So we will have negative, okay. So this becomes limit x tending to 0. So sin x plus 3x by 2 is sin 4x by 2, which is sin 2x. So we have minus 2 sin 2x, and sin x minus 3x by 2 is sin minus 2x by 2, that is sin of minus x, which is minus sin x divided by x twice x. Cos 3x plus x by 2 is cos 2x, and sin 3x minus x by 2 is sin x. So this becomes 2 cancels out, negative sign cancels out in the numerator, sin x cancels out. So we have limit x tending to 0, sin twice x divided by x multiplied by cos 2x, okay. So cos 2x when x tending to 0 will be 1. So this is limit x tending to 0 sin 2x divided by x. This is now very easy. We will create the denominator 2x and we will adjust it. So this is limit x tending to 0 sin 2x by 2x, and I just have to multiply with 2 because x is already there in the denominator. Sin 2x by 2x when x tending to 0, limiting value of sin 2x by 2x is equals to 1. So this is equal to 2. So this was pretty straightforward and very easy problems based on the standard result of trigonometric functions, especially tan x sine of limiting value of sin fx by fx when fx tending to 0 is 1, and limiting value of tan fx by fx when fx tending to 0 is 1. But you must be very strong and well aware of all the trigonometric identities and formulas to solve this kind of problems. So that is all for this video. I will make probably 2 more sets of problems based on the standard result of trigonometric functions, which will be a bit harder. So in the next 2 videos, so please stay tuned. If this video was beneficial, then please like it, share it with your friends, and please support me by subscribing to my channel, and do not forget to press the bell icon so that you will be notified by my future videos. I am ending the video here. Thanks for watching, and until the next video, take care and bye.